Hello friends, welcome to CEC live lectures. I am Dr. Pavitra Bharadwaj. I am Associate Professor in the Department of Computer Science at Jesus and Mary College, University of Delhi. So friends, in this series we had just started in the past two lectures and we are talking about Python programming. So we all appreciate how important Python has become today, and every day by day it's growing in its popularity because of various reasons. Firstly, because it is very easy to learn, very simple to use and implement, and the code which is written in Python is very easily readable, it is very fast executed, and also because Python has got number of implementations, it has got number of applications in data sciences, in machine learning, and so many places where scripting is required, so Python is used. So we had also seen that what are the different modes in which Python programs can be executed. So it was an introductory lecture, and now today we are going to talk about the different types of data objects which are available in Python and how these objects can be handled, and what are the inbuilt mechanisms in Python which help us handle the different kinds of data. So we have seen that the core, the fundamental unit of any programming language is its data, and every language has got its own set of data types and its own mechanisms through which it is going to handle data, and it has got its own protocols also in which data and variables can be declared and they can be used. So those who are new to any programming environment should understand that what exactly we mean when we are talking about data, or say for example when we are saying we want to store a value within the program, we want to hold a value in the program. So how do we do that? So we actually create a variable. A variable is nothing, you can say it is like a container which has got a name. Now in that container with a name you can put any type of data, that is you can put a number, you can put a string, you can put a floating point, or you can put any other kind of data in that, right. So variable is nothing, it is a container which is a named container, right, and this container can hold your data. So whenever you want to refer or whenever you want to use that data, you actually have to refer it through the container name or through the variable name that you are accessing. So likewise, different types of data are available, different data structures are available when we talk about Python. Okay, so in Python we can classify these data structures in two main categories. First is the primitive data structures. Primitive means that which are available in almost all programming languages. These are the basic types of data which are supported by almost all programming languages, and then there are some non-primitive data structures which Python gives us, which are specific. Some of these we may have used in C++ and C and other languages, but some are very specific to Python and they give very specific kind of functionality to the Python environment. So in primitive, of course, we have the integer, we have the floating point, we have the string, and we have the Boolean kinds of data. So about these four kinds of data we had discussed in the previous lecture also, that what are these four different kinds of data. Just a quick recap, we will say that integers basically are for whole numbers or integer values. Floating point are for decimal numbers or which have got a point or a decimal. Then strings are basically collections of characters, so which strings can be represented in a single quote or it can be represented in a double quote and sometimes triple quotes also. So string is basically the character kind of data, or we can say the text kind of data, and then you have the Boolean data, which is of course the true, false or yes and no type, right. So these are the four primitive types of data which is provided by Python, which is supported by Python. In addition to this, we have other types of data which are more non-primitive or more different kinds of data. So first in this case is the array data type. So array, of course we know that array is a group of different data types which can be stored. Array is a collection of different data items. Okay, we know how we use them in C and C++ also. Then we have a very unique kind of data structure in Python which is called the list. Now the list structure is basically, it is also a collective data type, or we can say it is a composite data type, a data type which can hold multiple values within itself. And in list we have the the linear list and we have the non-linear list. So in linear list we have the stack and the queue, and in non-linear we have the graphs and the trees. Then we have the tuples. So tuple is again a composite data type which we will look at. Then we have a dictionary data type. Then we have the set data type, and we also have a data structure for files. So these are the different types of non-primitive data structures which are supported by Python, and in today's lecture we are going to talk about these data items, that is we are going to talk about the list, the tuple, the dictionary, the set and the file. We will also try to touch upon the stack, queue and tree, but we will not go in too much of detail of these because these will be discussed in the forthcoming lectures. So if we look at assignment, right. So when we say assigning a variable, so what does assigning basically means? So assigning means that we are binding a variable, okay, in Python, okay, we are giving it a name to hold a reference to some object, right. So we understand the concept of an object. So everything in Python is considered to be an object, right. So when we are assigning a value to a variable, we mean that we are creating a reference to that and we are giving a value. It does not mean that we are creating a copy, we are only creating a reference when we are assigning, right. So in Python when we are creating the names, they do not have an intrinsic type, right. So objects have types, but the variables which you are creating, they do not have the type. So based on what data you are assigning to the variable, it will automatically take that type. So we say that this is an intrinsic typecasting, that is once the variable is given a value, then its type is determined, right. So we can create a name the first time it appears, okay, and then we can create an assignment expression. Say for example, if we write x is equal to 3. So this means that we have created a variable, the name of the variable is x and we have assigned a value to that variable which is called 3, right. So now when how are these variables deleted, or these references, how are they deleted? So once the scope of that variable is passed out, so automatically they will go into the garbage, right. So if you look at naming rules, like I said that we can use a variable name like x. So there are certain rules, certain conventions which are also followed whenever we are creating a name or whenever we are declaring a variable. So first thing is that Python definitely they are case sensitive. So Python is case sensitive, so the names are also case sensitive, and you cannot start the variable name with a number. So your variable name has to always start with a letter or with an underscore. The variable name can have a number, but it cannot begin with a number. And of course, there are some reserved words which cannot be used for declaring the variable names, like we have break, we have class, continue, global, print, raise. So these words cannot be used for naming the variables, right. So besides this, we have certain other naming conventions also which are followed. For example, all caps will be followed for constant. So these are only conventions which are followed so that the program becomes consistent with the standards, it becomes easily readable, right. So then you also have joined lower names for functions. So basically you put an underscore between the names so that you declare the functions names and the attribute. Then we also have some camel case that we had discussed. So in that case, first letter of every word is capital and the rest of it is small. And then we also have some interface. So we define like internal, or we define as private, right. So when you are assigning values to a variable, now in Python this can be done in very interesting manners. For example, you can assign to multiple names at the same time, like we write x comma y is equal to 2 comma 3. So then when you print x, you get the value, right. So, this also makes the swapping of variables easy, because you can simply write x comma y is equal to y comma x. So, the values can be swapped also very easily. Then you can also have the chained values. Say for example, if 3 variables have the same value, so you can write a is equal to b is equal to c is equal to 2. So, these are called as chained assignments, right. But for example, if you are trying to access a name before it has been created, like for example, if you simply write the name of a variable, say y, then it is going to give you an error. So, what is the error that you get? That y is not defined. So, y is not defined or name is not defined error comes when you are trying to access a variable before it has been defined, before it has been declared. So, therefore, always you will first declare the variable and then only you can use it. You cannot call a variable before it is declared, right. So, these are a few basic conventions that we follow. These are a few basic rules that we will follow for naming the variables and for assigning values to a variable, and then how you can access those variables. Now, we come to our main subject, that is the subject of composite data types. Now, basically we have one particular type of data structure which we can consider as sequence data structure, because in this multiple values will be there will be a sequence of items that can be shown here. So, in Python basically there are 3 types of sequences that we deal with. The first sequence we say it is called the tuple, then we have the string is nothing but a sequence of characters, and we have the third type of sequence which is called as the list. So, tuple, string and list, these are all similar in certain respects and they are dissimilar in certain respects, but the main idea is that these are all sequence types of data structures. So, now what is a tuple? Basically tuple, we all know tuple means a row. So, in this case it is a simple immutable ordered sequence of items. Okay. So, you can have items of different types, you can have items of mixed types, okay, and we can also have further collections within a tuple, right. So, how do you declare a tuple? You simply give the name to the tuple and you give the values to the tuple which are separated by commas. Now, we say that it is immutable because you cannot change the values in the tuple, like for example, string is what? String is also, it is very much like a tuple and it is also immutable, because in this also change is not possible. So, a string definitely we understand that it is defined in a double quotes. And then you have the list. So, list is actually a mutable ordered sequence of items, and again this can be of mixed type. So, tuple, string and list, they can all have mixed type of items, mixed type of data in them. For example, you can see here in the third example we have shown a list where you have 4 different types of item, 2 are numbers, then you have a string called John, and then you further have a tuple within a list. So, where you have up and down. So, these are mixed type of items which we are showing here. But the most important point to remember here is that strings and tuples are immutable, that is you cannot change them, but list is a mutable ordered sequence of items, right. So, all these 3, that is tuple, string and list, they share the same syntax and functionality. Other than this, the only difference is that 2 are immutable, but lists are mutable. So, there are certain operators which can be applied to all the sequence types. That is why we study them together, because there are certain operations which will be applied to all the 3 and they will be giving the similar kind of results. So, first sequence type is how you define the tuple. How do you define the tuple? So, we define the tuple using parenthesis and then we separate the items within a tuple using commas. So, we can have any type of item as we have already defined within a tuple. So, they are in a parenthesis and they are all separated by commas. So, the text items are put in double quotes, the string items are put in quotes, and the numbers are put and the floating point numbers are put. So, we define the list using the square brackets and comma. So, this is one important difference. By looking at it, you can understand whether it is a tuple or it is a list. A list will always have square brackets, whereas a tuple will have parentheses. Okay? And then you define we can also define strings. So, we know how strings are defined. So, strings can be defined using single quotes, they can be defined using double quotes, and they can also be defined using triple quotes. Now, what is triple quote basically? Triple quote is used for a multi-line string. So, when your string is passing through multiple lines, so then you will use a triple quote. So, this is how the three are defined. Tuple is defined using parentheses, list is defined using square brackets, and strings are defined using the three types of quotes, right. Now, if you want to access the individual members of a tuple or a list or a string, we will always use the square bracket notation. The square bracket notation is very similar to the array notation that we know, and you will always have an index number. And we know that all these, that is the tuple, list and the string, they are 0 base, that is the first index is always the 0 index. So, if it is a tuple, if you write tuple and you write square brackets and the index is 1, it means that you are accessing the second element or the second item in the tuple, right. Then you have, if you want the same way, the same way it will be applied to your list also, and the same way it will be applied to your string also. So, when you are looking at string, so then it is going to return the second character in your string. So, in this case, when we are using an example, say hello world, so the string which is returned is at the first position, the character which is at the first position is E, so that is going to be returned. Then we have the positive and negative indexes also. So, we understand that when you count from 0, so it is going to give you the positive index. So, you are going to count from the left starting with the 0. But if you give a negative index, then it is going to count from right starting with -1. So, in this example, if you give an index value, if you want to retrieve an item which is at index position -3, so you will start counting from the right, and that is -1. So, you will start counting from -1, -2, -3, so that is going to be 4.56. So, likewise you can have positive indexes also and you can have negative indexes also. Then there are certain operations which we like to perform on the strings, or we would like to perform them on tuples as well as on lists, right. So, the most commonly performed function is the slicing function, right. So, it is important to note that Python has got its own functions, it's got its own modules through which you can easily perform these operations on your tuples or strings or lists, right. So, the first is the slicing operation. So, what we are going to do in slicing, of course, we are going to create a subset of the original string or the original list. So, we are going to start copying at the first index and stop copying before the second index. So, if you want to slice, say if you want to have the first, second and third character, so you will write T and in index you will write 1:4. So, here 1 is the index from which you want to start slicing, okay, and 4th is the index before which you want to finish it. So, you will start at 1, which is ABC, and you want to stop at 4th. So, before that is your 2.3, okay. So, 1, 2 and third item is going to be returned, right. So, please understand this thing is important, that whatever we are giving in the stop position, it will stop one index ahead of it, and negative indexes will also count like that only. So, it will start, if you say tuple 1:-1, then also it is going to start like that only. It is going to retrieve the first element and then it is going to retrieve till the from the right hand side, which is starting at -1. So, 1 before that will be 2.3. So, both ways it is going to give you the same value. So, this way we can return a copy of a subset of the string. Please understand, the main item is not going to be changed, it is only a copy of a subset that we are getting here, right. So, if you want to omit the first index to make a copy starting from the beginning of the container, then you simply write :2. So, in this case what will happen, your string, your slicing operation will always start from the 0th index and it will give you the 2 characters or the 2 items from that, right. If you want to omit the second index to make a copy of starting at the first index and going to the end, so then you will write 2 : so when you write 2 : it will start from 2 and go to the end. When you write :2, it will start from the beginning and go up to the second index, right. If you want to make a copy of the entire sequence, that if you want to copy the entire tuple or the entire string, then you simply write T and you write colon, in square brackets you write colon. So, automatically the entire tuple or the entire list will be given to you, right. Now, this is a difference. Now, in this case, you know, there is a difference between the 2 lines for mutable sequences, right. So, we know that strings and lists are immutable, tuple is a mutable. So, you will have, say you have I2 is equal to I1. So, both refer to the first reference. So, changing one affects both these, right. So, what you are doing is, you are not creating independent copies, you are actually creating the 2 references to the same item. Okay. Now, besides this, besides the basic slicing and the copying operators, you have a multiple operators which also work. The slicing and the copying are standard operations which we are doing through the operators, but there are certain Boolean operators also which are there. So, that is going to give a return a value as Boolean true or false value, right. So, the first operator that we look at is the in operator. So, the in operator will give us a Boolean test whether a value is inside the container or not, that is whether an item is present in the tuple or list or not. So, what we are doing in this example, we are simply creating a tuple, we are saying 1, 2, 4, 5 and then we are checking whether 3 is there in T or not. So, obviously it is giving a value as false. So, this is the in operator. Then you can also have a not in kind of an operator which is going to give you the reverse of the in operator. So, if you say 4 is not in T, so then because 4 is in T, so it is going to give you a value as false, because not true will give you a value as false. So, this is how the in operator works. So, in case of strings, if you want to test for this, then you can check for a substring also. So, you can say whether C is in A or whether CD is in A or whether AC is in A, right. So, in this case the in is actually a keyword, okay, and it is in is also used in the syntax of for loops and the list comprehension. So, both places we will see that the in word is being used. So, where you are using it in the loops, it is a different context. When you are using it for lists, it is a different context. Then we have the plus operator, which is actually a concatenation operator, which produces a new tuple or a list or a string, and the value will be concatenation of its argument. So, if you say 1, 2, 3, okay, and then you say plus 4, 5, 6, so then it is going to give you a new tuple which is called 1, 2, 3, 4, 5, 6. Likewise, it will work for lists also and it will work for strings also. So, this is a concatenation operator. It is simply going to add the arguments of the 2 lists or the 2 tuples or the 2 strings. Then we have another operator which is the star or the asterisk operator, which produces a new tuple, list or string which will repeat the original content. So, it is basically for creating repeated elements or repeated indexes or the repeated items in the particular container, whether it is list, it is tuple or it is string. So, say for example, if you have a list 1, 2, 3 and you say star 3. So, it means that you want to create 3 copies of this particular container. Likewise, it will work for strings also. If you say hello star 3, so it will print the word 3 times. So, this is like a simply it is like a multiplier operator which is going to create more copies of that particular object in this. So, in this we have seen that what are the different types of operators that are working here. So, we know that you can perform a slicing operation, you can perform a copying operation, you can perform a addition or concatenation operation, and you can perform the multiplication or the product kind of operator, which is the star operator performance. So, we will be discussing more about the composite data structures in Python in the following lecture. Till then, please keep watching CEC. Thank you.